Circuit analysis, electrical circuit analysis, Unit 5, star based problem. Important question and answer, expected exam problem. 15 marks. Manager welcomes you all. Problem 9. A balanced short connected load of impedance 15 plus J20 ohm phase is connected to a 3-phase 440 volt 50 Hz supply. Find the line currents and power absorbed by the load. Assume ROIB phase sequence. That is a 7 marks expected problem. VR and VY and VBN represents the voltage between any line and neutral. Between the line current phase angle is 5. That is phasor or vector diagram balanced star load. The currents IR, I1, IB are equal in magnitude and have 120-degree phase difference. The dispersion of these vectors is shown in figure. Sometimes a fourth wire called neutral wire is run from the neutral point if the source is also star connected. This gives three-phase four-wire star connected system. However, if the three line currents are balanced, the current in the fourth wire is 0. Removing this connecting wire between source neutral and load neutral is therefore not going to make any change in the condition of the system. The availability of neutral wire makes it possible to use all the three-phase voltages as well as the three-line voltages. Usually the neutral is grounded for safety and for the design of insulation. It makes no difference to the current flow in the load phases as well as to the line currents, whether the sources have been connected in star or in delta, provided the voltage across each phase of the delta connected source is root 3 times the voltage across each phase of the star connected source. Referring diagram, taking VRN as the reference voltage. VRN is equal to 440 angle of 0 degree divided by root 3. That is 254 angle of 0 degree. VYN is 254 angle of minus 120 degree. 0 minus 120 degree. And VBN is 254 angle of 0 minus 240 degree. That is angle of minus 240 degree. Impedance per phase is ZPH is 15 plus J20. This polar format as 25 angle of 53.13 degree ohm. The phase currents are IR as VR and divided by ZPH. That is 254 angle of 0 divided by 25 angle of 53.13. IR is obtained 10.16 angle of 53.13 degree ampere. IY is VYN divided by ZPH is equal to 254 angle of minus 130 degree divided by 25 angle of 53.13 degree. That is 10.16 angle of minus 173.13 obtained IY value, that is in ampere. Currents IB is VBN divided by ZPH. 254 angle of minus 240 divided by 25 angle of 53.13. That is answer IB is 10.16 angle of minus 293.13 degree ampere. The three-phase currents are equal in magnitude and displaced by 130 degree from one another. Since the load is star connected, these currents are also reference line currents. The power absorbed by the load P is 3 into VPH into IPH cos phi. That is in load term root 3 into VL IL cos phi. That is root 3 VL is 440, IL is 10.16 cos phi. Phi is 53.13. We obtain answer the power absorbed by the load power is equal to 4645.78 watts. Answer that is balanced star connected load. Expected exam question problem. Unit 5 Analysis syllabus. And engineering, thank you.